Find all points of horizontal and vertical tangency given the parametric equations y equals t squared plus t, and x equals t squared plus t, and y equals t squared minus 3t plus 5. So what we know is that if you have a horizontal tangent line, the slope is 0. And if we have a vertical tangent line, the slope is undefined, or you could say that it's actually getting infinitely large. Well, our slope is dy dx. So if we want dy dx to equal 0, then that means the numerator of our slope has to equal 0 while the denominator does not. Well, our slope is also dy dt over dx dt. So our dy dt has to equal 0, and our dx dt cannot equal 0. Now, to do a vertical tangent line, that is the exact opposite, because to get an infinitely large slope, we have to divide by something incredibly small. So that will be our dx dt. We want our dx dt to head towards 0 and our dy dt to not be 0. So the first step for this problem is to find both dx dt and dy dt, and we'll look at the different values. So if you start with x equals t squared plus t, then the derivative of x with respect to t, dx dt, equals 2t plus 1. And what I'm going to do next is actually set that equal to 0. So 2t plus 1 equals 0. So t equals a negative 1/2. I'll do the same thing with y. So y equals t squared minus 3t plus 5. So the derivative of y with respect to t equals 2t minus 3. I'll set 2t minus 3 equal to 0 and solve for my t. So I'll add 3, divide by 2, and t equals 3/2. So what this tells me is that when t equals negative 1/2, our dx dt is equal to 0, but our dy dt is not, because these are the only zeros for each of those separately. So when dx dt is equal to 0, that's when our denominator equals 0, which will produce an infinitely large slope, or an undefined slope, so it would have a vertical tangent line. So I know that I'm going to have a vertical tangent line when t equals negative 1/2. Now, when dy dt equals 0, that's a 0 in the numerator divided by something that is not 0, so that is actually equal to 0, and we would have a 0 slope, so that would be a horizontal tangent line. And that will happen when t equals 3/2. So the question actually asks for you to find all points of horizontal and vertical tangency. So our points are going to be in xy form. So for both of these t values, the point we'll be looking for is t squared plus t, our x, comma, t squared minus 3t plus 5, our y value. So for our vertical point, I'll evaluate this at a negative 1/2. So I'll say negative 1/2 squared plus a negative 1/2, so minus 1/2, comma, negative 1/2 squared minus 3 times a negative 1/2 plus 5. And whatever this yields will be our point for a vertical tangency. And I'll do the same thing for horizontal. So 3/2 squared plus a 3/2, comma, 3/2 squared minus 3 times 3/2 plus 5. Then as soon as you evaluate all of these expressions, you have your xy points.